When you stop writing your paper to check on something else, let's say how the machine is running your experiment in the lab, and then come back to the writing task, your brain doesn't magically reset your focus. A significant part of your cognitive capacity stays stuck on the lab logistics. You're wondering if the experiment is running correctly, or what steps comes next, or what time you have to go back and check it again. This means that when you sit back down to write, you're always writing with a compromised and fragmented brain. You've left half of your processing power at the lab bench or in whatever second task you did. This brings us back to the cognitive load theory, which we broke down in episode 1 of this series. Our working memory has a strictly limited amount of bandwidth. When we try to write in a chaotic, interrupted environment, we flood our brain with all the mental noise of our surroundings. But to synthesize a complex scientific argument, our brain desperately needs that bandwidth for the deep, high-level processing required to connect our data to the literature. Another important thing to have in mind is called thought-to-text gap. You know, that exact friction point where your brilliant scientific ideas get completely stuck somewhere between your brain and your fingertips before you can deliver them to the page. Well, higher education and graduate programs almost never provide explicit instructions on how to bridge this gap. Universities expect us to just know how to do it. They give us the lab space, but they leave us completely stranded when it comes to the actual cognitive strategy of writing. This exact systemic failure is the entire reason I started this channel, and it is why I build my strategic digital products. I want to provide the concrete, step-by-step frameworks that academia completely fails to teach us. Frameworks explicitly engineered to lower that cognitive load so you can finally get your science out of your head and onto the page.